Geometry students, in this video we will be looking at quite a few definitions, so you will be doing a lot of writing today. We will also be looking at a formula that you have used before called the distance formula. Go ahead and copy this heading in your notes if you would please. Your heading for today is segments, angles, and distance formula. Segments, angles, and distance formula. And the lesson number is 2.3. So go ahead and write all that down if you would, please, and also include today's date. All right. Before I give these terms to you, I want to warn you. Some of these terms are easy, some of them are old, you already know them, and some are self-explanatory. However, instead of saying to yourself, this is dumb, why do I need to write these down? Look at it like this. Bonus points, okay? These terms that we are about to cover are easy questions on a test or a quiz. So please take really good notes and be thankful for the easy stuff, okay? The more difficult math will be coming. Trust me, it's coming and it's not going to be easy, okay? So have a good attitude about this, take really good notes, and understand, take advantage of the easy math while you can, okay? All right, moving on. Here we go. Now notice I did not asterisk any of these, and that, by the way, is the correct spelling. I did check it to make sure. A little weird looking word there, but I did not asterisk any of these, but you are responsible for all of these terms that I'm about ready to give you. So on tests and quizzes, you are responsible for these terms. Got it? Good. Get it? Here we go. Let's roll. Here's the first term. Congruent segments. Congruent segments are segments that have the same length. Please copy that in your notes. I would also like you to quickly copy down the examples that I give you. Congruent segments, segments that have the same length. Please copy this down. I don't care if the segment is running that direction and the other segment is running that direction. And we're just going to pretend those two segments are the same length, okay? We're going to call this segment AB, and we're going to call this segment CD. All right, there we go. Those two segments, we'll say this segment here has a length of 5 inches, and this segment here has a length of 5 inches. These two segments are called congruent segments. Please copy all this down. I'm going fast. Copy this down quickly. So you could also write it like this. Segment AB is congruent to segment CD. And of course, segment AB is the same thing as segment BA. You could also say segment DC if you wanted to. Okay? Congruent segments. Segments that have the same length. Moving on. Congruent angles. Please copy this in your notes. Angles that have the same measurement. Now, somewhere in your notes, go ahead and draw an angle, maybe that looks like this. And then draw another angle that looks the same. You don't have to get out your protractor and measure. It's not that important. And let me go back a page, by the way. I apologize. I want you to learn to put a little mark through a segment and a little mark through the segment like that, okay? Because if it has one mark here and one mark here, that's a symbol that these two segments are congruent, okay? All right, back to the angles. So go ahead and copy two angles in your notes that are relatively the same, and I guess we're just going to go ahead and say this angle here is, I don't know, 45 degrees. So we'll say this angle here is 45 degrees. And we're going to call this angle A and angle B. Remember, you can give angles one letter names as long as there's no confusion as to what angle you're talking about. And angle A is definitely this angle here, and angle B is definitely this angle here. So we're going to call these two angles angle A and angle B. So off to the side you could write angle A is congruent to angle B. That's the symbolism you need to get used to. You need to know what it looks like, you need to be able to read that, and you need to be able to write it also and use that, okay? There's also something else you need to make note of here. I'm going to use 2 marks this time. Pretend the 45 degrees wasn't here and pretend it's not here. If an angle has 2 marks and it has 2 marks here, that means those two angles are congruent. Or if the angle had 1 mark and 1 mark, that means the two angles are congruent. Or it might have 3 marks. Usually the most you go up to is 3. Occasionally you'll see 4 marks. But either way, you can mark your notes however you want to. You can put 1 mark for both angles, or 2, or 3. But when you see that type of symbolism, please understand that means the two angles are congruent. Okay, congruent angles. Moving on. Midpoint of a segment. Please copy this definition in your notes. Point C between points A and B such that segment AC equals segment CB. Please copy that down. Now that sounds a little weird, but that is the definition of the midpoint of a segment. Let me give you a picture of this, okay? Copy this definition down and then copy this picture, please, or this example. Okay, here's a segment, okay? In your notes, we're going to go ahead and put A here and B here. Now read the definition carefully. It says point C between. Now, yes, we talked before in the past that between in geometry also means the 2 points or the 3 points are all coplanar. And we talked about that. Excuse me, I'm sorry. I apologize to you. Collinear, okay, is what it means. Collinear, okay? So when it says C is between A and B, it means all 3 points are on the same line, and C is right in the middle in such a way. Now look, that AC, this segment right here, equals CB, this segment here. So in other words, the midpoint of a segment is, now you need to know this definition here. This is what you'll be tested on a test or a quiz, okay? However, another way to say it would be this: the midpoint of a segment is the point that's right in the middle of a segment. Okay, that's another way you can say that. So the midpoint of a segment is a point that is right in the middle that divides the segment into 2 equal parts. In fact, I would go ahead and put a little mark here and a little mark here, and that tells you AC is congruent to or equal to CB. Okay? All right, let's continue on. These are not difficult. These are easy, simple definitions. I'm almost done. I think we just have about 1, 2, 3 more, and then we're going to take a look at a couple formulas, okay? All right, go ahead and copy this in your notes if you would, please. Segment bisector. A segment bisector is a segment, ray, line, or plane that intersects a segment at its midpoint. A segment, ray, line, or plane that intersects a segment at its midpoint. Take some really good notes on this, please. Here's your segment, okay? Now I'm going to embarrass myself. I know some of you are really good artists, and I'm going to look pretty dumb, but that's okay. I'm not a good artist at all. However, let's look at what a segment bisector is. I'm going to try to draw this, okay? It's a segment or ray or line or plane that intersects a segment where at its midpoint. So we're going to say the midpoint is right here, okay? So if I were to draw a segment like this that goes through the midpoint like this, we would call this segment a segment bisector, because this segment right here that I'm circling right now, this segment cut the other segment right in half. Let's pretend that this segment was a line and there were arrows on the end, okay? This line is a segment bisector because it cuts this segment right here in half. It could be a ray, okay? Let's pretend for a second that we have an end point here and an arrow here. So now we have a ray. This ray is cutting this segment right here right in half. So this ray is called a segment bisector. Listen, students, whatever figure, the segment, the ray, the line, or the plane that is cutting the segment in half is called a segment bisector. Now here's where I'm going to embarrass myself, and I'm going to try to draw a plane. I'm sure I have no business doing that, but It would be, this will be rich, won't it? Okay, here we go. I don't even know where to start, to be honest with you. If someone, let's see here. Well, we'll try it. This plane is, picture it's a sheet of paper sideways, and then you have a pencil going right through it. If this point right here, if the plane is passing through this point right here, which we already said was the midpoint, then this plane is a segment bisector. It's cutting the segment in half. Okay? I hope all of that made sense. Let's continue on. An angle bisector. Please write this down. It is a ray that divides an angle into two congruent angles. A ray that divides an angle into two congruent angles. Please copy this in your notes and then draw this picture. Here's our angle. And now let's pretend that we have a ray coming out of it right here, like this, in such a way that this angle right here is, I don't know, 25 degrees, and this angle here is 25 degrees. That means this, excuse me, this ray right here cut the big angle right in half. So this ray right here that I'm coloring over, this ray right here is called an angle bisector because the ray cut the angle in half. Does that make sense? And so you could also, don't forget what we learned here just a couple minutes ago, you could also put one mark here and one mark here, because these two little angles, this angle here with one dot and this angle here with two dots, those two angles are congruent. They both measure 25 degrees. Okay? I hope that makes sense. Let's continue on to your last definition. Now this would be a definition that you've known for years, but I still want you to copy it in your notes. Perpendicular lines. Two lines that intersect to form a right angle. Two lines that intersect to form a right angle. And I really don't have to give you an example of this probably, but I will. Here's a line, and here's a line. And I'm not sure if that's exactly right, but I think you get the idea. I think it's pretty close to being perpendicular. There we go. It's a little better. So these two lines are perpendicular if their intersection forms a right angle. And so if I put a little mark here like this, you know that's the right angle symbol, then I know those two lines are perpendicular because they form a right angle, or in other words, they form an angle that measures 90 degrees. Okay? So perpendicular lines, two lines that intersect to form a right angle. Okay? Now let's continue on. Those are all of your definitions. Let's move on quickly and finish this video up. We've just been studying definitions in non-coordinate geometry. Remember, what that means is all of the lines that we've looked at have not been on the coordinate plane, the x, y coordinate system. Okay, so let's switch over now to coordinate geometry, and let's study some line segments that lie on a coordinate plane. So here we go. Here are the two formulas that students quite often get confused. Please don't do that. Memorize the difference between these two. All right, first of all, we've already discussed this formula. Let me get a drink here real quick. And that is called the midpoint formula. Okay, now you can copy that down if you want to. You don't have to. We've already talked about this formula earlier in the year. But this is called the midpoint formula. Students, common sense. It is the formula that finds the middle of 2 points. That's why it's called the midpoint formula. If I tell you here's a point and here's a point, we'll say 1, 2 and 5, 3. How do you find the middle point right here? You use this formula. This formula helps you find the midpoint when you're given two coordinates on the coordinate plane. Now, this formula here is the distance formula. Please copy this in your notes. You need to have this in your notes. It is the square root of this entire expression. And what you do is you subtract your two x's, and then whatever number you get out, you square it, and then you subtract your two y's, and this should be a y. I apologize, it's a typo. This should be a y right here, okay? You subtract your two y's, and whatever number you get out, you square, and then you add those two numbers together. And then whatever number you have right here, you take the square root of that number. And that gives you the distance between two ordered pairs. So back to my example over here, 1, 2, and 5, 3. So if I have those ordered pairs, 1, 2, and 5, 3, and I ask you to find the point that's in the middle of those 2 points, you would use this formula. If I ask you to find the distance between those 2 points, you would use the distance formula. Please memorize those, know those, and be able to use those on tests and quizzes. Okay, let's continue on. Now, let's apply the distance formula to a problem, and then let's tie the two formulas together in one problem. Go ahead and copy this in your notes if you would, please. And you do not, unless you want to, need to copy the coordinate plane. For those students who like to have a visual, then go ahead and copy it down. For those that don't need it, that's totally fine. That's your decision, okay? Okay, but do copy this down in your notes, please, if you would. We're going to find the distance between -5, -8 and 1, -2. Okay, so for those that want a visual, -3, -5, 1, 2, 3, 4, 5, 6, 7, 8. I've never seen an uglier coordinate plane, so please excuse my crude making of this. And that should probably be over just a little bit more to right here. 1, 2, 3, 4, 5. There we go, that's good enough. And then 1, -2 is right here. So here's your segment right here. And we're going to find the distance from this point to this point. So let's go ahead and get to work. Some of you are probably already working, which is fine. The formula is x minus x, quantity squared, plus y minus y, quantity squared. And it really doesn't matter what x you put in first right here or what y you put in first here. You're just going to subtract and square anyways, so it really does not matter. Here's your x, here's your y, here's your x, here's your y. Okay, here we go. X minus x. That's -5 minus 1. So -5 minus 1 squared plus y minus y. -8 minus a -2. Please watch your signs. -8 minus a -2. Quantity squared. So moving quickly, we should be able to do this in our head. If you struggle with sign numbers, don't hesitate to use a calculator. That's totally fine. -5, -1 is -6. If you square -6, you will get positive 36. -8 minus a -2 would be a positive 2. So -8, positive 2 is -6. And when you square -6, you will get 36. Add those two together and you will get the square root of 72. Now, I'm fine with your leaving it like that. If you want to type it into a calculator and get out a decimal, that's totally fine. That's up to you. But this would be the distance of that line. I will say one more thing about 72. Hopefully you remember this from from Algebra 1 or Algebra 2. You can take 72 and break it down into 36 times 2, because 36 times 2 is 72, and then we know the square root of 36, so the square root of 36 is 6, so we put a 6 on the outside, and we're left over with 6 square root of 2. But for now, I'm okay with this. This would be the reduced form. I just wanted to kind of refresh your memory about that, okay? But moving on, the distance between these 2 points would be the square root of 72. Okay, so we did it. We found the distance between these 2 points. And that would be approximately, if you're wondering, it would be approximately, let's see, 7 times 7, 8 times 8, 9 times 9. It would be somewhere between 8 and 9. Let's see, 64, 8, about right in the middle, actually, to be honest with you. So around approximately 8.5 is the distance of this line right here. Okay? All right, now let's continue on. So what we just did is we practiced finding the distance between 2 points by using the distance formula. Pretty simple, okay? Now let's continue on. I would like you to write this problem here in your notes. And if you want to include the coordinate plane in your notes, you can. If you don't want to, that's fine. That's totally up to you. So here we go. Let's try something a little different. Let's use these same points, and let's do this. Let's find their midpoint, and then we're going to use the distance formula to verify that the midpoint is correct. Okay, I'll explain this as we go. This will be interesting, okay? So the first thing we're going to do is we're going to find the midpoint between these 2 points right here. So again, if you want to copy down this drawing, you can. You don't have to. I think we're about right here. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, -2. So there's the segment, and we're going to find the midpoint, all right, which is about right here. So let's go ahead and find the midpoint. Here we go. X plus X divided by 2, comma, Y plus Y divided by 2. So -5 is my X and 1 is my X. So -5 plus 1, -5 plus 1 divided by 2, comma, my two y's being added together would be -8 plus -2. So -8 plus -2 divided by 2. All right, and let's see what we get. We get -4 over 2, which is -2, and we get -10 over 2, which is -5. And that looks about right. I'm just about over -2. 1, 2, 3. I'm just about -5. So that looks just about right. So here's my midpoint, -2, -5. So did we accomplish the first part of the problem? Yes, we did. We said, excuse me, that we're going to find the midpoint, and we did that. Then we said we're going to use the distance formula to verify the midpoint is correct. Now let me show you what I mean. Please listen to me carefully, students. If this point right here is truly the midpoint, which it is, then that means the distance from here to here should be the same as the distance from here to here. So let's check it and see. Look what I'm going to do. Are you ready? Watch this carefully. This ordered pair here was what? -5, -8. Put a little negative sign there. And this midpoint here is -2, -5, right? And this point here is 1, -2. So I'm going to find the distance between -5, -8 and -2, -5. That's the distance from here to here. Got it? I'm going to find that distance right there. Then I'm going to find the distance from -2, -5 to 1, -2. And that's the distance from here over to here. And you know, if this point here is truly the midpoint, which it's supposed to be, then the distance I get out for these two ordered pairs and the distance I get out for these two ordered pairs here should be the same distance. So let's go ahead and get started and let's see if that happens. Okay, so let's find the distance between those 2 points and the distance between these 2 points also. And let's see if we can't get rid of most of this mess here. All right, give your old teacher about 3 seconds. I have no idea what I'm doing. I'm getting paid way too much money. All right, here we go. Let's see here. Pull that, grab that, and there we go. Okay, let's find the distance between these 2 points right here. X minus X, -5 minus a -2, quantity squared, plus Y minus Y, that's -8 minus a -5, quantity squared. Let's see what happens. Doing this quickly in our head, -5 minus a -2 is -5 plus 2, that's -3. And when you square a -3, you get 9. Plus, -5 minus a -5 is, or -8 minus a -5 is -8 plus 5, which would be a -3. When you square that, you will get 9. Add those together and you get the square root of 18. Now let's see if we get the same thing over here for these 2 ordered pairs, and hopefully we will. All right, let's see if we do. Here we go. First of all, we have X minus X, which is -2 minus 1, quantity squared, and then plus y minus y, negative 5 minus negative 2, quantity squared. All right, here we go. Negative 2 minus 1 is negative 3. When you square negative 3, you get 9, plus negative 5 minus a negative 2 is negative 5 plus 2, which is negative 3. When you square a negative 3, you get 9, and 9 plus 9 is the square root of 18. So we did verify that negative 2, negative 5 is the midpoint. Because remember, here was your segment right here, and here was your midpoint right here, and we found the distance from here to here to be the square root of 18, and we found the distance from here to here to be the square root of 18. So we did it, okay? And that's it for today's video. Once again, we looked at a bunch of terms I felt were pretty easy, whether old or just self-explanatory, easy to understand, and we looked at the distance formula. And make sure you understand the difference between the midpoint and the distance formula, and make sure you know when to use them and how to use them accurately, okay? If you have any questions, don't hesitate to call or email.